Example 1.1, bouncing ball with no vectors. This example actually goes through how to bounce a ball just using normal X and Y, and then the book is going to go into how to convert that using vectors, specifically using Euclidean vectors, which we'll be creating in GGEZ. Now for this one, we're just going to copy pretty much exactly what they have. We're not going to use a structure to hold the bouncing ball. Everything is just going to be in the main library. Let's go ahead and get this going. So I've already got my template all set up. Let's head on over into the main library and get started. So the first thing is I noticed that we have a float X and Y of 100, 100. I'm thinking, and what size ball do we have here? Ellipse, 16 pixels by 16 pixels, it looks like. So I want to actually have like the size, that can be an F32 for our circle. Let's see, what else do we need to care about here? Let's have our mesh, and we'll translate that over. So that's going to be our graphics mesh. And we're going to need a location. So that's our X, which is an F32, and our Y, which is an F32. And then we need the speed. So the speed X, which is an F32, speed Y, which is an F32. And I think we're good to go then. Let's go ahead and we're going to create our ball mesh here. So that mesh equals, and we're going to need the size also as part of this this mesh. So size equals, they have theirs as 16. I think that makes it, I think that's a radius as well. So it'll be a 32 total size. Come on, 16.0. Mesh is going to be a mesh builder, new. Now in processing, you use ellipses to draw circles. And here, as we've seen, we can actually just call a circle method, and that's how we're going to draw our circle. So we need to draw mode. Fill, our point, let's make this 0, 0. A radius is going to be our size. Our tolerance 0.1 to make it a true circle, and our color, we're going to make this what color do they fill it like 175. We could definitely do that to make it sort of like not pure white. All right, let's set that up here. So color new. Now this wants numbers between 0 and 1. I can actually do a color from RGB and then give it 175, 175, 175. And then we have a color sort of set up for us. And we'll build you, pass it in the context. And there we go. Okay, so now we have our mesh. All right, so we have our size, we have a mesh. We need the X and the Y. So let X. Now they have their starting at like 100 to 100. I think that's fine. It'll start in the top left corner, and then it'll be sort of like moving down and to the right. That should be fine. We'll do 100.0, Y equal to 100.0. Let's see, our speed. Speed X equals, I notice here that the speed X is 1 and the speed Y is 3.3, so it's not exactly the same. It's not going to be in a like just a downward right angle. It's going to be a lot more down than right, and that's fine. We'll make you 1.0 to go to the right. Let speed Y is equal to 3.3. That's fine. And then all we need to do is add them in here. So we have our background color, time to add our size, our mesh, our X, our Y, and our speed Y. Let's go ahead and bring those down together just to make sure, make them look a little bit nicer. All right, so now it's just yelling at me because I'm not using those. So let's go ahead and start actually doing the thing. In our update loop, we want to update our locations. So we're going to say self.x is going to be plus equals to self.speedx. Self.y is going to be plus equals to self.speedy. Now that should just make it go down into the right. If we were to just draw this out right now, which we absolutely could, graphics, draw, pass it into context. The drawable is a reference to self.mesh. Then we need our draw param and give it a destination, which is self.x, self.y. So if we were to do this, everything should work just fine. We're not using the size yet, but we will. We'll see our ball moving across the screen, but it doesn't bounce. It just is going to fly off the screen and off into the infinity. So in our update, let's actually handle colliding with the walls. So here we can just say if our self.x, let's say we do like left and right to begin with. So if you're less than 0, then I actually want to reset you to 0 and then reverse the speed. This doesn't happen in the example code that's given, but it's something that I've noticed in making some games and other simulations. If you don't do this, you can get this weird state where it sort of like vibrates as it's trying to reverse its velocity, but it's also like behind the line that you want it to hit. So just sort of resetting self.x is equal to 0, and then we can say self.speedx, we're going to multiply equal to -1.0. So that's going to reverse that. Now, the other thing is, if we're on the left-hand side, we know we cannot be on the right-hand side. So we're going to do an else if and check there. Self.x, if you're greater than, now we need the entire width of the screen. So let's actually get that here. Equals graphics, drawable size, passing in context. Okay, so if you're greater than width, then we're going to do exactly the same thing. Self.x is equal to width, and self.speed x times equals -1.0. Now we can take this entire code and completely duplicate it for the y. It's very similar here. So everywhere we have x, that's going to be maybe a little bit too much there. Everywhere we have x in this code, we're going to replace it with a y, and the zeros are going to be fine, but where we have width, we're going to replace that with height. And that should work out for us. We should be able to now bounce off the walls. Let's go ahead and check it out. And there we go. We're bouncing off the walls. So notice that this circle goes into the halfway point before it bounces. And that's because we're checking the center position of the circle. We're not checking the edges of the circle. That would require a little bit extra math, and might be something fun to sort of like take this code and maybe update that. But until then, this is example 1.1, the bouncing ball with no vectors in Rust and GGEZ. I'll see you in the next video. Bye.